This is the Galvanic Cells and Activity Series lab. We're going to use these different metals and their corresponding solutions to make our galvanic cells, or half cells, and then make those into galvanic cells. And then we're going to be finding the voltage using our multimeters. So that's the lab. Let's get started. So we have to make half cells of each of these solutions and their corresponding metals. I'll use the copper because it's blue, it's easier to see what's going on. For the copper 2 nitrate solution, these are all nitrate solutions. So we have the copper metal and then the copper 2 nitrate solution. So first thing is we'll put in the copper 2 solution. It really doesn't matter how much you use as long as it covers up the copper metal enough, or I should say makes a contact with the copper metal. So you don't want to have just a little bit at the bottom. So here's the copper 2 solution with the copper metal, and I'm going to do this for each of them, and one of them is going to be a little tricky. This nickel, this is pure nickel. That's fairly tricky to get a hold of. It usually has something else in it to stabilize it, keep it from degrading. So I got to figure out how to get this into, I guess it will fit. And then you see the magnesium here is just this strip. So going to be some little tricks to making up the half cell and then using it effectively, making the connection. But let me get these all set. We'll take a look here. And here are all the half cells. We have the metal electrodes in the metal ion solutions. So here's aluminum, copper, iron, lead, magnesium, nickel. You can see I'm gonna have a little trouble with that nickel electrode. I'll have to figure that out. And then tin, and finally zinc. You can see zinc. So those are the 8, and we're going to make each of those a half cell compared to each of the other 7. And we're going to see what the voltages are across each of the galvanic cells that we make. To connect the half cells, we're going to use these U-tubes that contain agar gel that was mixed with potassium nitrate. So these are going to be our salt bridges. So the lab supervisor has made up 3 really nice ones here. And so probably just use one for now, but you can see what they look like. It's a little kind of a gel inside there. And these are going to be flipped upside down and put into the solution to make that connection that will complete the circuit for the galvanic cell. All right, here's our multimeter, and it's currently set for DC volts. And this is the range that it sets, and I just picked this for now. We might have to change it. We'll find out. What we want is to be able to read off 3 numbers, 3 sig figs, when we do the measurement. And what we're going to do is hook up these leads to the 2 different metal electrodes that will make up the cell. And one thing, the voltage is going to change over time because the reaction is ongoing. It's a spontaneous reaction. The voltage is going to change, but we're going to go with the voltage that we first see. Hopefully it won't be so fast that we have to really be that concerned about it. But the other thing is that we may end up with negative voltage. What that means is that we've put the leads on the wrong electrodes, that what we thought was the anode is actually the cathode, and what we thought was the cathode is actually the anode. But we're going to leave it as negative, because those numbers are going to, the way that they're set up, we're going to arrange them from the most negative to the most positive, and that's going to give us our activity series. So we actually want that. But when you see the negative voltage, that doesn't mean that it's a non-spontaneous reaction that's running. It means that we've hooked up the electrodes to the wrong, the leads to the wrong electrodes. But that's okay, because we do want the negative values to allow us to put them, the different metals in order of their activity, and so that we can make the activity series. Okay, so here is our first galvanic cell. Let me just bring this here. You can see that it should be copper and nickel for the first one, copper is on the left, nickel is on the right. And then it said to put in the black or negative lead onto the metal on the left, and then the red or positive lead on the metal on the right. You can see I solved the problem with the nickel, just connected the lead to the end of the metal, this little bit of metal, and put it in. The lead is above the surface of the liquid. And then I put the U-tube in here. And then what I'll do, then this is all hooked up to the multimeter, and here is the voltage. And we'll go with -328 millivolts, because that's the range that we have here, is 2,000 millivolts. So -328 millivolts. And here's the next galvanic cell. This one is aluminum with copper. Notice I kept copper. I exchanged nickel out for aluminum. And that's what I'm going to do, is leave copper alone and just match it against every metal. And when that's done, then I'll put nickel in this place and match it with every metal, and so on, till every metal has been matched against every other. That is, every metal has been used, every pair of metals that are possible will have made up a galvanic cell. So now let's take a look here. This happens to students a lot. They do this and say, oh, it's 0 volts. What's going on? Well, you might notice something is missing, and that is the salt bridge, this U-tube here. And I just put in, this is just distilled water in each of these. So I had to take it out, and might as well wash it off as when it's been taken out while I'm exchanging out the galvanic cells. So I'm going to put this over here. Yeah, the light's in the way. But then I'll put this in, and yes, it should make a big difference. It's going to have to settle in. So our copper aluminum, we're going to go with -490, we'll say 493 millivolts. Oh, and I should say that also it's going to be 0.493 volts. Notice, as I said, the voltage is going to change because there is a reaction going on there, so you shouldn't be surprised with that. But we want the voltage that it was when these were both 1 molar solutions. Even as we're watching, the concentration is changing in both of them. But so we're going to go with the original 493, I believe it was, and that was millivolts, so it's going to be 0.493 volts. This is the copper zinc. And we'll go with the 780. See, it's reacting. This is a very high voltage, so we're going to see a lot of change very quickly. But since we want from the beginning of the reaction, we'll go with 780 millivolts, or 0.780 volts. This is the copper iron. And so we'll go with -491 millivolts. This is the copper lead. And we'll go with -523 millivolts. And here's the copper and tin. And we'll go with -603 millivolts. All right, here's the copper and the magnesium. Hooking up that strip of magnesium was easier than I thought it would be. And it's because magnesium and copper are so far separated in the activity series, we'd expect a pretty large voltage. Oops, there it is. So we'll go with, and it's very large, so -1,601 millivolts. Okay, and for completeness, we have copper and copper. Now, if there's two different metals, one of the metals will want the electrons more than the other, but when they're the same metal, there's no reason for the electrons to flow. They're not trying to get to, the metal that likes them better. They both like them the same amount, so the electrons stay put, and we should get a voltage of 0. And that's what we get, so that's good.